Alright, let us talk about formation of enols. Enols are one of the most important molecules. These are important because they undergo what we call alpha halogenation. Enols undergo alpha halogenation, where the halogen group is attached to a carbonyl compound after the enol has been formed. So today we're going to focus on the formation of enols. So now, an enol, it is a compound which contains OH, or we can say hydroxyl group, but the carbon which has OH and the carbon, adjacent carbon, or I may say alpha carbon, between the carbon which has OH and the alpha carbon contains also a double bond. What I mean is this. For example, you may be given a structure like this one. This is the OH, or hydroxyl group. But now, for it to be called an enol, it should have a double bond between the carbon which contains OH and the alpha carbon. This is the alpha carbon, or this one is also alpha carbon, so I'll just get one. So here you may have, you can something like this. So this is an enol. So this qualifies to be called enol. Another example of enol is if you may have this compound like this, then here OH, then this carbon contains OH, or hydroxyl group, then this carbon should have a double bond between this one and the other one. So here, double bond like this. That's an enol. So now another example, the last one. Example, this one. So in this case, you can have two different enols because we have two alpha carbons. So the first one, you may have something like this. This is an enol. Or another one, OH there, then double bond here. So you have two types of what, there. We will discuss this after in the next video. So now let us just focus on formation of enols. How can we form these structures? What conditions should be put in place? So now we need to know or understand that enols are formed under both conditions. What are these conditions? The first condition is acidic condition or acidic environment. Some they say acidic media. So number one, acidic environment. The second one is basic environment. So let us like this one. You can take note. We can say enols can be formed under both conditions. What are these conditions? Number one, acidic acidic condition. Okay, this acidic condition can be denoted by H3 or plus, but this is same as H plus. So this means that it is an acidic environment, or acid as a catalyst. Number 2. That's number 1. Number 2, basic environment. Let me just say condition. Okay, so now this basic condition, it is nothing but containing a base. A base can be denoted by OH. Yeah, those are the conditions that we're going to be talking about. So whenever we say basic condition, just know that it's OA or H. Acidic condition, let's say, just know that it's H3 or plus hydronium ion, or H plus. Here you can just pick any acid of your choice, even here, or any base of your choice. It will result into formation of enol. All right, let us now dive into examples. So here, let me say acidic conditions. You can be given a structure like this. Then they put H3 or plus. Automatically, our answer should be an enol. So in this case, we have then with a double bond like there. This is what we call enol formation. So how can we form this with an acid? Let us light the mechanism. Let's light the mechanism. Okay, so you get the structure, the starting material. In this case, it is this one, and then your acid here with one lone pair, and it carries a positive charge. Now here we have 2 lone pairs. So now oxygen with 2 lone pairs, we use one of each lone pair to to attack the hydrogen, expelling this or breaking that bond. Now our answer here shall be this, with 2 double bond connected to H. Then here, remember, we have remained with 1 lone pair. This is the same lone pair which is there. Now if oxygen is connected to it, if oxygen has what, has 3 bonds, 1 2 3, automatically it becomes positive. Okay, then what is another product apart from this? The other product which is formed is water, H2O. This product is neutral. So now, after this, now after the water and this compound has been formed, the same water are going to be used. So now, since this one or this part, this carbon or this carbon, they are both alpha hydrogen, alpha carbons. which contains alpha hydrogens. Well, I'm going to get, or I'm going to use one of it, like one of alpha hydrogen. If you want, you can use the alpha hydrogen from here because they are both acidic in nature. So now, one of the lone pairs of water is going to come and attack the hydrogen, forming a double bond here. So after a double bond has been formed here, meaning this carbon cannot support 5 bonds, this will make the pi bond to break. Okay, now from here, now our product will be in fact this is the final product because it has what? It has a double bond between this carbon and the alpha carbon, making it an enol, plus what? Plus the acid, which is what? H3O plus. This is the final answer. Now this product in an enol, this is an acid. Alright, so let us see this product. It is the same as this one, regardless of the position of double bond. So that bond can be here or there. It's just okay there. Just one of the same. Yes. Actually, that was the example number 1. Let's go to example number 2. Example number 2. Okay. Let me get this structure. Then here, H plus. I already said that if you see just H plus, it means it's an acid, meaning this reaction proceed with acid as a catalyst to form an enol. Now the answer here will be this one. Alright, now let us just do the mechanism. So here we have H. This is the acid. You can write in this form or that form. There's no problem. H plus. Then okay, here lone pairs. So this lone pair will come and one lone pair will come and attack the hydrogen, breaking this bond. So we have compound like this, O and H. Since the oxygen here has the 3 bonds, meaning automatically it becomes positive and plus what? H2O. H2O is a neutral. It can behave as an acid or as a base, depending on the specific reaction. So in this case, we are on here alpha carbon. So here there's what? There's a hydrogen here, and this will behave as a base because this is acidic part of a carbonyl compound. Now it uses one of its one pair to attack the hydrogen, expelling this bond, forming a double bond between this carbon and that carbon. So now this carbon on the middle here cannot support 5 bond. As a result, 1 bond will break. 1 bond will break. Let me dot it well. 1 bond will break. This will result into forming something like this. And this is our enol plus H3O plus. This is the answer. Simple and straightforward. All right, example 3. This one you're going to do it on your own. So I'll put my oxygen here, then that's H3 plus. What will be the answer here? And show the mechanism. What will be the answer there? Example number 4. Again, this one we are going to do on your own. In this case, let us put this compound. Okay. What will be the answers well here? Yes, so those 2 examples, please do them. And if you find any challenges, don't hesitate to let me know. Alright, so our second video will be our second class will be on formation of enols, using in basic media, formation of enols in basic media. That's number 2. That is basic condition. So we're going to start on basic condition. So basic condition will be our second topic, so that we know how to form enols using a base. All right. Shalom.